solving non-homogeneous linear differential equations by way of variation of parameters. Yeah, that's the goods up there. I don't think that's how you spell variation. I think I'll leave it. No, I'll fix it. Okay. Variation of parameters. We need a problem. I put that nice piece back up there. What? We're doing a problem that we didn't need to use variation of parameters on. Why? Just to convince ourselves that it works. What do we first need to do? We need to get our characteristic part so that I can find my y1 and my y2. Alright, so I pretend it's homogeneous. Then I assume y is e to the rt. I get my derivatives, I stick it where they go, and then I pull out my e to the rt, and we find that our characteristic equation is r squared minus 5r plus 6, and that's going to be equal to 0. We're making a whole lot of assumptions here. We get our r's to be 3 and 2. That gives us our y1 and our y2. Where does those go? You're going to stick those everywhere you see your y1. And, consequently, you're going to do the same thing with y2. Now what do we need to do? We need to go and get our Wronskian. So, we get it. Our Wronskian of y1 and y2. That's e to the 3t with its derivative just under it, and e to the 2t with its derivative just under it. So then we just take the determinant. Whoosh, whoosh. So that's 2 e to the 5t minus 3 e to the 5t. And then we gather, collect, and combine. And we just found our Wronskian. Now we're going to take that Wronskian, our y1 and our y2, and we're going to stick it everywhere we go. But whoa, what's our GS? Our GS is this guy. Boop. Let's do it. Bam. So then our capital Y, our particular. I put all that stuff in there. Ah, those should be S's. Bam, looking like a Tijuana taxi. Let's go ahead and clean this up. Yeah, on up over here. We integrate from 0 to t because that's just nice. Those should be S's. Because my variables of integration need to be different than the limits. Alright, I see a lot of E's. So we's go and we clean it up. Yeah, the algebra on that is minus 2 e to the minus 2s. Now we can integrate each one of those parts and evaluate it from 0 to t. And then upper minus lower. It's fundamental. It's the theorem of calculus. Let's distribute that in there. Alright. I need some more room. I'm rewriting what I had there. Now what? Combine like terms. And that's our yp. So now we put our yp and our yc together. Oh. That's c1y1, c2y2, and yp. Well, that's yp there. And then, that's, oh, look at that. Combining like terms. If I add a constant with another constant, I get an additional constant. And that's what was happening there.